So, having had a look at how an alternator operates, how it works, let's have a look inside one. Okay, so here we've got the rotor. We can actually see the two fans on it. We can see the poles, the claw that's actually hooked round, that actually intensifies the magnetic field. We can see there's a bearing on this end and a bearing on this end. And I also want to draw your attention to the two slip rings on the end. Now the two slip rings are the electrical connection for the windings that you can see in the center of the rotor. So now if we take a multimeter, we connect it up to read ohms with the black wire going into common, the red wire going into the ohm scale. We can actually see that the two slip rings, we have continuity between them. They are part of the same circuit, the field circuit. I'll just make sure I've got a good connection on there. There you go. Jumping around a little bit because there is some dirt on the slip ring. So the rotor is part of the field circuit and actually generates a strong magnetic field around here, which is going to induce a voltage in the stator. So the next component I want to just talk about quickly is this, the regulator. And ordinarily, this one's damaged, but ordinarily what we'd see, if I hold that up to the camera, is just in this point here. You can see the two square holes there. There would be the brushes. And the brushes would sit over the slip ring like that to give an electrical contact onto it. Attached to the brushes, this black part here is the regulator. And the regulator is going to regulate the amount of current that's flowing through the rotor. In doing that, it's going to increase and decrease the strength of the magnetic field. So that's two of the components that we're going to talk about. The next one I want to talk about is the stator here. And this is the part that the rotor turns inside. Now the stator is going to have the electricity induced into it by the turning magnetic field that's surrounding the rotor. Now it's quite hard to make out because this one's been made a little bit easier to strip. But if I hold it fairly close to the camera, you can probably see just here, here, and here, the connections that would have actually connected to the rectifier. Those connections show you that there's actually three sets of windings inside the stator. They can be connected one of two ways. They're either connected in a Y format or in a delta format. Y is also known as star. So the next component is the rectifier. And we need the rectifier because the voltage that's induced into our stator is AC, alternating current. To charge our battery, as we said in the previous video, we need DC, direct current. So in here there are a series of diodes, and you can probably just make out the cylindrical object, I should say, just there, 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 and there, and I think there, there, and there. So in this particular setup, 9 diodes. 1, 2, 3, 4, 5, 6, 7, 8, 9. If we bring the multimeter back over, We can see the operation of the diodes by connecting up the meter one way across that diode, where we can see there's no flow, and connecting it up the other way, where we'll see it allows current flow. Remember, our diode is like a one-way valve for electricity, and you can see it's the same for the larger diodes. If I connect onto the heatsink there and go onto that terminal there, you can see current can flow through by the fact that we've got continuity on the meter. If I swap those over and put the black to the heatsink and the red to that wire, there's no current flow through. There's no continuity. The diode is blocking the electricity from getting through. That was a quick look at the rotor, the regulator and brush box, the stator and the rectifier. Thanks for watching.